All right, gang. Potential of a short video if I don't get on one of my world famous tangents, and I'll do my best not to. I got to take my daughter to the fair, so get that pointer out of the way. So let's get through this. Write the systems of equalities that correspond with. Well, guys, this essentially comes from, and I've demonstrated this in previous videos, and I'll just use X and Y here. It comes from this. So essentially the systems of linear equalities would be 2x minus 9y equals 29, and 3x plus 8y equals 22. You might say, this stuff over there kind of confuses me. I know that this is my x's, and this column is my y's, and these columns are my numbers. Put in the equal signs and the corresponding arithmetic signs, and you've got your system of equalities. All right, same thing, sorta. Here is solve. And you notice that you've got x, y's, and z's, x, y's, and z's, and only y and z's. So we've got to put in a placeholder there. So this is 3x minus 2y plus z equals 6. 11x minus 20y minus z equals 0. And 0x plus y plus z equals 3. The way these things work is, guys, we got to have our variables in columns, so all of our x's, all of our y's, all of our z's, and all of our constants to the right. Once we get this situation, we can put this in augmented matrix form. Is that minus 20? Yeah. All right, I'm going to run through quickly how to do that again on your calculator, but you guys should be some major pros by this right now. So, but just in case, don't want to take anything for granted, don't want to leave anyone out. So I got a 3 by 4 here. So 3 minus 2, 1, 6, and 11 minus 20 minus 1, 0, and 0, 1, 1, 3. Second function, quit. Go back to matrix, go to math, find that RREF thing, row, reduced row echelon form. Go back to matrix, get your matrix. And the solution would be 2, 1, 2. So what we can say here is that x is equal to 2, y is equal to 1, and z is equal to 2. Right? Solve. Sometimes we get things that look like this. I kind of let the cat out of the bag, if you will. That's what we have up here. Notice this came from the augmented matrix, which tells us that we can take something like this and create an augmented matrix very easily. Okay, so it's really just undoing what I created up here. I know the reason I did it up here because I knew this was coming. So again, as we've got our coefficient matrix, our variable matrix, our constant matrix, can always be either put into an augmented matrix, or we can start with an augmented matrix and create this. So guys, to solve this, it's going to be the same Same thing. So 1, -4, -1, -5, 0, 3, 1, 7, 2, 1, 0, 10. So guys, go second function quit. Here I'm just going to go second function entry because I want that over again. So my answers are 4, 2, and 1, which again I get from this last column. So since I'm using x, y's, and z's, x is equal to 4. Y is equal to 2. And z is equal to 1. Guys, y'all should be really good at that. I mean, really, when you encounter something like that on your exam, you should be really good. All right, one last question, and you know, I'm going to throw some more stuff at you on a study guide, but it'll be, you know, a problem here, a problem there. But this is going to be the main source of your study guide. All right. All right, gang, I know this is a corny way to do this, but I just don't want to start over and go get another sheet of paper. You got the problem. I had video issues is the reason that this started over, and I'd already done some of the work, but I didn't want to show you the work until I actually explained what I was doing here. So it's coming at you in a weird way. I've tried to hide what I messed up, but anyway, I had video issues. I had a video that actually crashed. So guys, this final video. So I think these problems are easier if you organize your work. And you can see here that we have a price, and then we have a supply and a demand. And we can see that when the price is $228, we have a supply of 7,500, and we can see that the demand is 7,900. We can see when the price increases to 2.37, that as we would expect, the supply would increase. And of course, the way it happens, the demand will decrease. That's what happens. Linear functions, their supply tend to have a positive slope, and those the demand typically have a negative slope. Now, what we need to do is we need to put this all together, but what we have to realize is that our supply function will come in the form of our supply, and our price is given as our y. The demand, we have our demands that come first, and our price is second. So our price is the dependent variable, and the quantity, in this case, what is it, the bushels, is actually our independent variable. So bushels comes first, and price comes second. Now that's not going to be hard to do with our calculators, because what I want to do is I want to show you how to actually handle that, since we're kind of doing this kind of thing. So if I go to stat, and I've already put the numbers in. I don't know if you guys can see it or not. I'll tell you what. Let me. I don't like the way that was working out. Let me pull up the other calculator. So let's go to. Actually, you don't need to hit that. So hit something different. Let's clear and get out of this. So just go to stat. Go to edit. And what I want to do is put my two prices in at 228 and at 237. Okay, so my supply was 7,500, and 7,900. And my demand was 7,900. And my demand decreased to 7,800 when the price went up, 9 cents. Now, guys, what I want to do here is I want to be able to I'm going to do my supply function first, but this L2 has to come first. This has to be my X, and this has to be my Y. Same thing when I do my demand function. This has to be my X, and this has to be my Y. Now, don't get this confused with, our cost function when we're given two values where we're given a quantity and a cost. We're going to put L1 as the X and L2 as the Y. It doesn't happen with supply and demand. It kind of works opposite of what at least I would think. So, guys, first thing, second function quit. I'm going to go into stat, and I'm going to go to one variable stats. To calc and go to linear regression, just like we've done before. But, guys, I need my X to be what the values are I've got in L2. And I need my Y's to be the values I have in L1. So I come down and hit calculate, and you will see that I get these values. Now I'm going to try to do a split screen here because I think that's going to be appropriate in this situation. All right. So my supply, I'm going to have to take a look at this over here. But so my supply, my slope, again, pay attention to the scientific notation. So my supply and really I don't need to complicate it like that. Let's just keep it simple here. The supply is going to be y equal 0.000225 plus 0.5925. Now, I just need to do that again for the demand, and it's, again, very simple. But I need L3 there. Still need L1 there because that's my Y. And in this situation, I will have, for the demand, Y equals negative 0.1239x plus 9.39. Now, we could solve this algebraically by go ahead and doing that. That's fine if that's what you want to do here. That's not what I want to do here. I want to show you how to solve this on the calculator. So what I can do is I can solve these. I'm going to solve them, but I can enter them into my calculator. So 0.000225x plus 0.5925. And then for y2, I can put in negative 0.0009x plus 9.39. Now, the tricky part comes here in setting up the windows so we get a picture that helps us solve the problem. So if I go up here to window, let's think this through, okay? Let's go back over here and let's think through what we've got, the numbers that we use to create. Now, guys, it turns out these were my X's and these were my Y's. So I'm going to run my X's from where? The lowest X I got 7,500, so I'm going to go a little bit below that. The biggest X I got is 7,900. I'm going to go a little bit above it. My y's, the smallest ones I got 2.28. I'm going to go a little bit below that. And my biggest x is, my biggest y is 2.37. I'm going to go a little bit above it. Now, when I hit graph, I'm going to see two lines that cross. And that cross, that point of intersection, is called the equilibrium point. So, I can come in here and just, this is not really needed to solve the problem, but I'll solve the problem in just a second. I can go into value, and what happens when I put in, for example, 7,900? Well, notice it's $2.37 for the supply. I can come down to the demand, and it is $2.28. So when this was 7,900, it's $2.28 for the demand function. When we have 79, it's $2.37 for the supply. That's not what I want to do here. Is that I want to find the point right there. So guys, just like we've done before, second function calc, number 5. Enter, enter, enter until it says intersection. So the point of intersection is 7820. Comma $2.30. Well, it's 0.352. Okay. So this says when you have 7,820 million bushels, the supply and demand are going to be equal. And that price, of course, is at $2.35. All right, gang, that's all I got. Take care.